Assalamu alaikum. My name is MD Faysal Mahmud and my metric number is A18KA3004. Today I am going to present about my major presentation, which is on Department of Water Reticulation. My company name is MMA32 Consulting Limited and my group number is 32. So before going to the main part, I would like to talk about our company profile. In background, our company established in 2022 and it is a new civil and structural engineering company that has the knowledgeable engineers with various experiences and all involved into one of the most promising consulting companies in Malaysia in the area of civil engineering design, project management, supervision, quality assurance and also consulting services. In our mission is providing technologically creative design ideas and strategies as well as high quality work and exceptional services in our sectors. Our vision is to become a well-known integrated engineering solution provider locally, globally and also which is for our stakeholders on a continuing basis. In project description, the project area is located in Taman Dato Selam, whose zip code is 81,800 and it's beside in the Ulutiram Desaru Highway. Its latitude is 1 degree 35 minutes 11 second north and longitude which is 103 degree 49 minutes 17 degree east. Its coordinates are 1 degree 33 minutes 14.4 degree north, 103 degree 35 minutes 54.6 degree east. The total area is 481,648 meter square and its perimeter is 4,468.27 meter. In introduction, first of all, what is water reticulation? Water reticulation system is a network of pumps, pipes and water storage system designs for water storage and distribution. The water reticulation field includes water delivery system, design, operation and servicing. This covers all of the town or cities public pipework including drainage system, access chamber and also construction and maintenance. The aim of this system is to provide a consumer with an accurate amount of treatment water. It should be capable to sustaining the degree of purity and should be watertype. It's also designed on the basis of all even at the breakdown period. The water should be available. In additionally, a distribution system cost should be as low possible. Water reticulation products are preliminary designed for a varieties of residential, commercial, industrial and firefighting purposes to fulfill water qualities or requirements. The efficiency of a reticulation mechanism can be measured for given following rate based on the pressure available in the system. Now our scope of work is: first one is proposed suitable location for water tank. Second one, decide type of water tank and design the size of water tank. Third one, proposed suitable pipe networks, and the last one is decide types of pipe and size and its size. The objectives of our design are to determine the capacity of water tank, to determine the flow rates in pipes, to ensure the minimum residential pressure heads are satisfied, to determine the appropriate pipe size and pipe types, to determine the height to determine the height of the elevated water tank. Most important project notes are: this project will cover only water reticulation pipelines. The whole projects need to be divided into certain numbers of areas where road lengths and proposal levels vary. The purpose of water reticulation system is to supply treated water at sufficient pressure and enough to the consumers. Our next part is design criteria. So the first one of design criteria is pipe network system. The type of pipe network that we have used is a closed loop pipe network. Closed loop pipe network is used to analyze the reticulation pipelines for project. By using the network, the water supply could reach to a very commercial load, even if a part of pipelines is closed to maintenance. The Hardy cross or head balance method is used in order to determine the residential pressure head by using Bernoulli equation. The residential pressure head must be efficient, or else pipe diameter should be altered. Now in water demand part, we followed a guideline of ISPAN 2018. So for calculating peak flow rate, the formula is Q peak is equal to F into Q average. So F is equal to peak flow factor, which are from SPAN. The urban and rural factor is rural factor is 2.5, and federal scheme factor is 3.0. So we use here 2.5. In firefighting flow, the firefighting rate is the firefighting pipes is equal to the flow equivalent of the number of hydrants and use simultaneously, while the flow is in domestic water pipelines is equal to average flow rates. So this is the guideline of assuming firefighting flow factor. So in our work we use here 1. Head losses. The formula of head losses is as it's given here. So L is equal to effective pipeline, which is meter, Q is equal to flow rate in pipes, D is equal to pipe diameter, and C is Hazen-Williams roughness coefficient. So this can get from this table. So in our work we use here 130 as Hazen-Williams coefficient. The maximum allowable velocity in conjunction with Malaysian Water Association, according to this, the pipeline is to be 2.5 meter per second as the allowable velocity. So in processes of our work, we have followed here 5 stages or 5 processes. First one is obtain proposed level and decide the location of water tank. Second one, propose design of pipe loop and pipe layout. Third one, calculate water demand, average flow rate, peak flow, and fire flow rate. Fourth one, resultant analysis, and lastly design water tank. In first step, we need to obtain the proposed level and decide the location of water tank. So we received the proposed level from the Department of Earthwork, which is 78 meter. So we decided our tank location is in 78 meter. In second step, we need to propose design of pipe loop and pipe layout. So as you can see here, the first one is pipe loop which has 19 areas, and second one is proposed pipe network layout. So here we get number of pipes 72 and nodes 53, and all those are approved by our lecturer Dr. Muhriza. In our third step, which is calculate water demand, peak flow rate, and also fire flow rate. So the first one is the calculation of water demand at each node. So these are the nodes. This is area, and also industries type or something else. The second one is same, but here the water demand, then average flow, peak water demand, and peak fire flow. So in example of calculation, the first one, which is shown here, average flow. So in the, from the first calculation, we get water demand description area in node 1. For example, we can use node 1. So water description area, which is 2.33 hectare. Water demand in light industries here, the total demand. So this one into this one multiplication will get liter per day. And Q average, which is average flow. So Q average from following this equation, we can get 0.893 liters per second. So for peak flow rate, so water demand into 2.5 as the factor. So we'll get peak flow rate here, and the peak fire flow. For the peak fire flow, just peak water demand into 1, because we use here the coefficient which is 1. So we'll get this one in liter. In liters per second, this one. Okay. Our fourth step is result and analysis. So in result and analysis, we are following here EPANET software for calculating Hardy-Cross method. So here we have followed two cases. Those two are same. So peak water demand from the calculation we get as like this. So an important note, which is negative flow values, means the flow direction in coming from finishing nodes and ending at starting nodes. So this is our fire flow map. The last step, which is design of water tank. Basically, we use Bernoulli equation for calculation in this part. To get the expected values, first of all, we have the water demand, total water demand. So in case 1, volume of water tank is we have the in liters, so we convert it in meter cube. In case 2, volume of water tank as like same. Since case 2 volume is larger than case 1 volume, so proposed water tank will be designed according to case 2. So proposed water tank, we assume diameter 32 millimeter and height 7 meter. So volume of water tank as from the formula pi d square by 4 into h. So we get 5,629.734 meter cube, the volume. Since the volume of water in case 2 is 5,204 meter cube, which is less than the volume of proposed water tank. The design is approved for meeting the criteria of water tank design. Hence, the bottom water level BWL and top water level TWL is about 250 centimeter. The total height of the tank is equivalent to 7.5 meter. So as you can see here, our water tank design. So diameter 32 meter, maximum level 7.5 meter, initial level 4.5 meter, minimum level which is 0, and water demand 5,204.024 meter cube, water capacity 5,629.734 meter cube, as we get previously from water tank calculation. So the supply pipe for the water means design pipe properties. We use here mild steel, so its coefficient is 130, as we get previously from guideline. Length 35 meter, diameter which is 350 millimeter, level 66 meter. Pressure head at tapping point in main pipe 30 meter. Minimum available pressure head, critical flow rate is equal to 2.53 liter per second. Top water level of elevated water tank 85.5 meter, as from calculation we get all those. So design pipe properties, we use here HDPE. Coefficient is also 130, and other values are same as previous. So from the calculation we get the area 0.096 meter square. As you can see here, the flow velocity in the pipe V is equal to Q by A. So from the calculation we get this 0.22 meter per second, which is less than 2.5 meter. So now from Bernoulli equation we get H1. From the simplification we get H1 value which is 10.5, which is less than 7.5 meter. So no need to provide pump at suction since height meet the requirement. In conclusion, as shown in layout plan, we decided to use closed loop pipe network system for our project water distribution system layout. This is due to the proposed area size and need to supply water to numerous industrial areas and have many buildings. The Hardy-Cross method was applied by using the Ethernet software to calculate the flow rate and pressure of each nodes. To analysis for tank design, we recommended using 32 meter diameter with 7 meter of workable height and capacity of 5,629.734 meter cube, which will satisfy the total demand of industrial uses. There are two cases which have different values capacity, but in here we design for case 2 because volume of water tank in case 2 is higher because of firefighting consideration to give sufficient pressure. The local fire department in Malaysia request that the hydrant minimum diameter to be 150 millimeter. As a result, we decided to use mild steel pipes whose diameter is 300 millimeter as the fire flow pipe and the pipe that concentrates the main pipe, which has a diameter 350 millimeter, because they can withstand a higher pressure demand. According to Malaysia Water Association (MWA) design guideline, all pipes must be burned at a depth of 1 meter. Lastly, our objectives of this project has acid where the capacity of water tank flow rates in each pipe is calculated. Ensure the satisfy their a minimum head pressure while assuming the approximate pipe size and diameter. Finally, the height of water tank is determined. That's all from me. Thank you for listening.